That isn't complex.
Well, does it look like a plus bi?
No.
How can we make it look like a plus bi?
Just you do what the problem said. You just.
Wouldn't you just add a 0 or whatever?
It's just the square root of 15.
Yep, square root of 15 times root negative 1 makes it square root of 15i. Okay, and then yes, you write it as 0 plus square root of 15i.
And you have to have that other variable still. And you have to have that other number. Like you have to, if you can't, if you have like, if you have 7, you have to have 7 plus 0i. And if you have 7i, you have to have 0
plus 7i, yeah.
Alright.
To have it in standard form, yeah. Okay, so this thing's complex conjugate would be 0 minus 15i. So basically, for this one, all you have to do is multiply root 15i times negative root 15i. And what's that going to be? What's the square root of 15 times the square root of 15?
15.
What's a positive times a negative?
Negative.
What's I times I?
Negative 1.
Yeah, so this is going to wind up being positive 15 when we're done. That seems like a really ugly problem to have the answer be 15.
Well, there are all those 15 everywhere.
I know. It's just, and yet somehow I'm surprised to see it at the end. Okay, 48 is designed to give you a headache, but not be impossible. 1 plus the square root of 8. Is that a complex number in standard form?
Yeah.
No. It's not in standard form. Is there an I component there at all?
No, you don't need it. It's 2 root 2.
Well, then, yeah, this is all real. This is all real. So I need to add plus 0i. This is my a, and my b is 0. Isn't that annoying?
Very.
So its complex conjugate is going to be 1 plus root 8 minus 0i. And I'll be honest on this one. Does it really matter whether you add 0 of something or subtract 0 of something?
No.
Now, so basically you're being told to multiply 1 plus root 8 times 1 plus root 8. So that's going to be 1 plus the square root of 8 squared. Can I just distribute the squared?
No.
Oh, thank you, Layla. If anyone had said yes, I might have thrown something out.
Yes.
You may not. This is a foiling problem. So this is 1 squared plus 2 root 8.
Yeah, Mr. Balova, you can't hit anybody. I have evidence.
That's true. Probably shouldn't.
Yeah, how's it 2 root 8?
How is it 2 root 8? What happens if you FOIL this?
I don't know, I don't like foiling radicals.
It's the same as foiling x's or y's. First is 1.
Foiling is fun.
Foiling is fun. So first is 1 squared, right?
Right.
Outer plus 1 root 8.
Oh, okay.
Inner plus another root 8. Last, square root of 8 times square root of 8 plus 8.
Okay.
And we're, see, I would write this as 9 plus 2 root 8. And as Sam pointed out, the square root of 8 is the same thing as 2 root 2. So I would write my final answer as 9 plus 4 square root of 2. And that's the answer when you multiply 1 plus square root of 8 by its complex conjugate. Tell me the earlier ones were a little easier. Can we do 4?
Slightly.
Number 4? Are you serious?
16 as well.
Really?
You have seen 16?
I have seen 16.
I just want to go over 4.
What's the answer then?
I will show you. I will teach you to a fish rather than hand you a fish.
I said, can we go over 4? Are you serious?
Take
It's like the easiest problem. Actually, take a look at 2, and then.
All right.
Yeah,
Find the real numbers a and b such that the equation is true. Let's take a look at number 4. Okay. A plus 6 plus 2bi.
It definitely says 8 plus.
It does. A plus 6.
No, it is 8 plus 6.
Yeah. Plus 2bi equals 6 minus 5i.
That's why I had problems. Because I wrote it as A plus B.
That would be a real problem. You'd have to break out linear systems to solve that or something. So a plus 6 equals 6. So I'm getting a equals 0. I'm setting my real components equal to one another. And 2bi equals negative 5i. So 2b equals negative 5. So b equals negative 5 halves.
Could you write negative 2.5 on it?
Absolutely you could. Okay, number 16. 16, I guess, let me see, let me double check the directions on it. Write the complex number in standard form. And it's negative 16 is square root of negative point, how many zeros? 0, 0, 0, 4?
Yeah.
Technically, you could just write this as square root of 0.0004 times square root of negative 1. Okay, and that gives you your 0.004 square rooted times I, and there's no real component. So it would be 0 plus this.
Oh.
But I think they expect you to simplify that a little bit. Pardon?
I'm missing a 0.
I am missing a 0 here. Thank you, Amy. Amy should proofread everything I do. They might want you to write it as 0 plus, let's take a look at just this separately. Square root of 0.0004 is the square root of 4 over the square root of 1,000 or 10,000? 10,000, right?
Yeah.
Sure. I don't know how many zeros there are.
0.1 is a tenth, 0.1 is 100, 2 zeros is 1,000.
Was it really supposed to be this hard?
So
Shouldn't
3
you know
zeros.
this?
Pardon?
Shouldn't you know this? You're a math teacher.
I absolutely should know this. Okay, so this is the
Although we
square
should
root of
probably know
4.
this as well.
This is the square root of 2 times 2 over the square root of 100 times 100. So what's the square root of 2 times 2?
2.
What's the square root of 100 times 100?
100.
So that's 1 over 50. So the final answer would be 0 plus 1/50th I.
See? Isn't that kind of hard?
It's kind of annoying more than hard, actually. Okay, I admit it. I stumbled over counting my zeros. I always have to double check this.
Maybe number 12.
See, the thing about a math teacher, Layla, is not that you know everything, it's that you know how to figure it out. Which I sometimes don't, which is bad. Write the complex number in standard form. Number 12, this only has a real component. On my little drawing the other day, this only exists on the number line. It doesn't go up or down into the I plane. So this would be 45 plus 0I.
That's what I thought it would be, but then I wasn't sure.
Seemed too easy, didn't it?
Yeah.
Yeah, it's annoying about it. Okay, I want to just do a couple examples of what happens when you're asked to find all of the solutions to a quadratic equation. Not all the zeros, but all the solutions. What's the difference between a zero and a solution?
0 can be a solution.
0 is a solution, yeah. But what's the difference between what does a 0 mean of a quadratic?
It's like the point on the x-axis.
X-intercept.
Yeah, which Dean was just defining. It's the x-intercept, which Dean was going more detail on. Can there be solutions that are not zeros?
Yeah.
And they are always blank. Fill in the blank.
Never hit the X.
Unreal.
Unreal.
Imaginary.
Imaginary is what I was looking for. They're always unreal solutions. So if I say find all the solutions,
Wait. What about a parabola that doesn't have to hit the X?
that's true, but it still has 2 solutions. Those 2 solutions are complex. For every parabola has 2 solutions, whether it hits the x-axis twice, 0, or 1 time. Let's look at this one.
Wait, is this new?
No, I hope not. Hope to God not. We'll find out. This is an example. It's number 63, which is not part of the homework for tonight, on page 148. But how would I solve this?
How do you solve that?
Yeah.
You could FOIL it.
What are you trying to
Or, I
do?
mean, not
Trying to
FOIL
find
it.
out.
Yeah.
Well, yeah, it's just factor it.
Can this one be factored? Does anything multiply to 2 and add up to -2?
No.
No.
No, 2 -1 adds, yeah.
You can pull.
So you got to plot the quadratic formula for this one. Now, since I'm asking you to solve this in the middle of a chapter on complex numbers, when I pull out the quadratic formula, which is x equals